Today, we will discuss instrumentation interview questions and answers. Video is very helpful for you, so don't skip the video. Here are 10 multiple choice questions on control valves, along with explanations. Question 1 is, what is the primary purpose of a control valve in an industrial process? Options are A. To shut off the flow completely. B. To regulate the flow of a fluid. C. To measure the flow rate. D. To provide additional pressure to the system. Its answer is B. To regulate the flow of a fluid. Explanation: control valves are primarily used to control or regulate the flow of fluids in industrial processes, not to completely shut off the flow. Question 2 is, what is the key component of a control valve that directly interacts with the fluid flow? A. Actuator. B. Valve body. C. Valve trim. D. Positioner. Answer 2 is C. Valve trim. Explanation is, the valve trim, including the valve plug and seat, directly interacts with the fluid flow and is responsible for adjusting the flow rate. Question 3 is, in a control valve, what does the CV or flow coefficient represent? A. Valve material. B. Valve size. C. Valve flow capacity. D. Valve trim type. Answer is C. Valve flow capacity. Explanation: the CV or flow coefficient of a control valve represents the valve's flow capacity, helping in selecting the right valve for a specific application. Question 4 is, which of the following is a common actuator type for control valves? A. Pressure gauge. B. Electric motor. C. Temperature sensor. D. Flow transmitter. Answer is B. Electric motor. Explanation: electric motors are commonly used as actuators for control valves, allowing precise control over valve position. Question 5 is, what is the role of the valve positioner in a control valve system? A. It measures the flow rate. B. It adjusts the valve trim. C. It positions the valve plug accurately. D. It measures the temperature. Answer is C. It positions the valve plug accurately. Explanation is, the valve positioner ensures that the valve plug is accurately positioned to control the fluid flow as required. Question 6 is, what does the term leakage class indicate in control valves? A. The type of fluid being controlled. B. The valve's maintenance schedule. C. The valve's resistance to wear. D. The valve's leakage rate when closed. Answer is D. The valve's leakage rate when closed. Explanation: leakage class indicates how tightly the valve closes when it's in the closed position. Lower leakage class indicates better tight closure. Question 7 is, in a control valve, what does the characteristic curve represent? A. The valve's material properties. B. The valve's size and shape. C. The relationship between valve travel and flow rate. D. The valve's operating temperature range. Answer is C. The relationship between valve travel and flow rate. Explanation: as the characteristic curve shows how the valve travel or position relates to the flow rate it controls. Question 8 as what does a control valve in fail closed mode do when power is lost or during a failure? A. Stays in the same position. B. Closes completely. C. Opens completely. D. Operates at a constant flow rate. Answer is B. Closes completely. Explanation: in fail closed mode, the valve closes completely when power is lost or during a failure, typically for safety reasons. Question 9 as what is the role of the control valve's trim components? A. To control the flow rate. B. To adjust the valve size. C. To protect the valve body. D. To isolate the actuator. Answer is A. To control the flow rate. Explanation: the valve trim components, including the valve plug and seat, control the flow rate through the valve. Question 10 as in a control valve, what does position feedback refer to? A. The actuator's location within the system. B. The position of the valve body. C. The valve plug's material. D. A sensor measuring the valve's actual position. Answer is D. A sensor measuring the valve's actual position. Explanation: as position feedback refers to a sensor that measures the actual position of the valve plug, which is crucial for accurate control in a closed-loop system.